All right, for my 272 project, I changed it from checkers to doing a flash drive and a USB port. All right, so for the background, you can see a picture of the system layer. In that system, I am pushing a flash drive into a USB port using my finger. And so what's the application? Well, all students, if they have a flash drive and they need to use it, they have to put it into a USB port in order to use. So it's a common situation that could be very useful for students to look at. Not only that, it can also be looked at in different ways. Maybe later look at it to where it's being pulled out of there, which follows axial loading, which is very relevant to this class. So there's also different ways. It's such a simple system that you could put forces anywhere if you want to look for moments and other stuff. But in this case, there's an axial force, and so that may lead to deformation. So now, the system is important because, like I said, all students see this system on a daily basis, and it's especially important because flash drives contain important information. And the last thing we want to do is lose all our notes we took over the semester that we have on there. So it's very important to understand how we can preserve the flash drive and understand what's going to wear the drive itself. And by doing that, and we can do that by understanding how forces look at it and doing sort of a mechanics force analysis. All right, so for a simple problem definition and short analysis, as you can see, we already have the picture of the system there, but on the left is the most basic diagram that I could draw where I modeled the USB port where the drive is plugged in as it's not moving. So even though it's a laptop and there might be movement in the laptop itself when you try to plug a flash drive in, I'm just gonna say it's so small that it might as well be attached or solid and not moving. So as stated earlier, there is an axial force along the axis of the flash drive, and the force that I'm applying to it here is a compressive force. Therefore, if there is deformation, it'll be a shortening of the flash drive, which is interesting because that would be kind of like the opposite of Poisson's ratio, where it states that if it's pulled, it's going to kind of stretch and get smaller. But I would guess that in this situation, if I push it, it would do the opposite and maybe get shorter and expand, is what I want to say. It's also good to know that the USB in this situation is plastic. So if we ever need to use like Young's modulus or found any material constants, that's the one we're going to be using. Probably a more specific plastic can be assessed later. So for the analysis requirements or the things that I'm going to analyze about it, definitely doing a stress strain analysis, maximum allowable force, and maximum elastic deflection. This is because the main idea of my analysis of the system is to understand the forces on it so that we can prevent it from breaking. And since it is plastic, it may not be as elastic as I would think. So it's very important to understand the maximum elastic deflection and also the allowable force it can handle before heading into that plastic area where it might be the difference between the plastic region may be so small that it just breaks, which is something that we do not want. So to wrap up, as stated, for the design tests, identified and described the application, identified the analysis criteria as well as the constraints, and I gave a very basic analysis on what it looked like. And I talked about how I'm going to look at the strains and stresses and deformation on it. Thank you.